Myself, Sai Tejas. I'm currently studying in Nitte Meenakshi Institute of Technology. I'm in the branch of Computer Science and Engineering. As a part of SSC course, I have completed my capstone project, which is Smart Garbage Classification using AI and Deep Learning. Nowadays, waste management is a biggest problem faced nowadays. All the recyclable, non-recyclable, disposable, which are harmful to the environment, all are mixed together and put it in the dustbin nowadays. So that it is the biggest problem we are facing nowadays. So I have built a system which classifies the garbage into different categories. So it detects the garbage, whatever I am showing it to the model. My model classifies the garbage into 6 categories: paper, cardboard, plastic, metal, organic, and metal. I'll go on explaining the code. First, I imported all the libraries required to the model. NumPy is used for numerical calculations, TensorFlow for deep learning, and Matplotlib for plotting the graphs. sklearn, I have used it for class weights. These are the dataset paths, like where the training dataset, validation dataset, and the model dataset has been saved. The image size I have given is 256 into 256, and the batch size is 16. In my code, I have divided the code into 2 parts, stage 1 and stage 2. In the stage 1, I'm giving the epochs as 15, and in stage 2, it is 30. I have also used data augmentation in my model so that it creates variation in the images like zooming, shifting, horizontal flip, and rotation, so that it can predict well and consistently. This training generator loads the training images into batches and then shuffles it. And validation generator loads the validation images and it doesn't shuffle because to remain the consistency of the output. Here I have trained the model using class weights because to handle the imbalance, if a label is having many images, so the model is biased towards it. To reduce the bias, I have used class weights. Instead of training my model from scratch, I have already used a pre-trained model, which is MobileNet V2. It is a lightweight CNN, which is good in handling the accuracy and consistency. We are entering into stage 1. In stage 1, I have freezed all the MobileNet V2 layers and then put it for training. I have used 128 neuron layers, and the activation function is ReLU. This softmax function converts the given output into probabilities. I have used early stopping in my model. So it monitors the validation loss. It checks for the last 5 epochs. If the validation loss doesn't improve, then the training gets stopped, and then it restores the best validation loss in the epoch. And reduce LRL plateau does, it monitors the validation loss. It checks for the last 3 epochs. If the validation loss doesn't increase, then it reduces the learning rate by 20% to its current value. We are entering into stage 2 after completing stage 1. Here I have fine-tuned the MobileNet V2 layers. I have freezed all the layers except the last 15 layers. And the same thing I have used early stopping and reduce LR on plateau. This part of the code is used for calculating the accuracies and the validation loss. And this part of the code is used for plotting the graphs, validation loss, and all the accuracies. I'll show you a quick demo of my model. Here I'm having two options. One, I can upload the image or I can use the webcam directly to predict the garbage. I'll upload an image which is a spoiled fruit. I'll click on predict. It predicts it as organic waste and the confidence is 98.16 and it gives the recommendation dispose it in the organic or compost bin. I'll give one more image. So it shows it as a glass and confidence is 97. I'll use the webcam now. So it is predicting it as plastic. This is organic. And a metal tin. And the paper. It also generates the reports which I have used it for testing. So these are the images. I can also click on this and it shows what class it is predicted and the confidence. And I can also clear the history. This is my model accuracy graph and model loss graph. Here you can see the training accuracy and the validation accuracy gradually got increased after each epoch. And the dotted blue line shows the fine tuning is starting after that epoch. So it also proves that after using the fine tuning, it all gradually got increased and the training loss and validation loss gradually got decreased after each epoch. This is my classification report. We can also see the recall is quite good for all the classes. This is the confusion matrix. Thank you for providing this opportunity.